Hey everyone, I'm David Room. Tonight we're just going to be working on some random things on my 3D space art projects using Python, Blender. Um, for those of you who might be new to these videos, I am making 3D art using Python code. So instead of using Blender for modeling, I have a very big set of uh, Python tools and my own custom mesh processing library that I use to make 3D art, both sort of low poly art for a game that I'm developing, as well as high detail 3D art for kind of finished 3D art pieces. And lately I've been focusing on the high detail 3D art pieces. And I've done a bunch of random work over the past few weeks. I've been very busy, so I haven't had a chance to stream. I'd like to get back into streaming. I don't have anything in particular, like a particular task that I'm trying to do, but I have a few different things that I want to work on, and hopefully something is of interest for you. I'm probably not going to talk a whole lot tonight. It's kind of late. I just want to listen to some music, have a chill time, and stream while I do it, just to see if anybody else is interested. So if you're tuning in, either live or later, I hope that you have an interesting project of your own to work on. Maybe you take some encouragement from this to work on your own creative projects or programming projects or whatever. And if you are doing that, I'd love to hear about it. So I'm going to get some music going and we'll get started. And I apologize if anybody's watching. I actually stopped and restarted this stream a little earlier because it looked like I was having some technical difficulties with streaming, but I think that might just be the YouTube studio preview. So let me just check Twitter. And then, okay, then we'll get started. So we're gonna listen to some White Bat audio as usual. And I'll give a little explanation of what I'm doing here. But for the most part, I'm just going to be writing code. Okay. So I'm working on a couple of different high detail pieces where I'm generating this space scene with ships in Blender. And I'm experimenting with several new techniques. I have some techniques that I've implemented manually in a Blender file that I might try to bring in. There's a couple of compositing tweaks and improvements that I've made. And also some code. There's some obvious like refactors and improvements that need to be made. And I think I'm going to start with that. It's not too glamorous of stuff, but the complexity of all this is starting to get to the point where I need to take a step back and say, what are some abstractions that I can implement that will help me manage this complexity? Because I'm doing the things I want to do, but it's too complicated to take those techniques over to a new piece. It's just too time consuming. So let's try to fix that. Let me just bring this down here. Okay. So let's jump in here. And I just brought this over from my other machine, so I'm going to make sure that everything works here in terms of running and things coming up on the right screen and everything. Okay, so this is the scene, and as you can see, I ran some Python code and it generated this Blender scene. And I'm just going to test to make sure that it renders okay here. My keys are working. So we don't have any surprises later. Like I said, I've been working on this mainly on a different machine, so Just want to make sure that everything's a-okay on this one. Okay, yeah. Things are looking good. So let's bring up my checklist here. So there are a couple aspects here of where I'm using this new panel greebling function, and actually just show you. So this is actually an earlier version of this model. I'm going to run this code now, and it's going to generate a new version of the ship that has this a different style of random panel greebling on it. And this is the code that I'm running here that we're going to be refactoring a little bit and cleaning up as well. So you can see these cuts here. And in Blender, looks like this. So it just adds a little detail on some of these side panels. But there's just too dang much code here. And there's repeated code, kind of repeated functionality between some different ships that are using this code. So let's see here. There's this other ship that I'm using this new greebling function on as well. And I'd like to abstract some of this stuff out. That edge where color is too bright. It should look a little bit more like this, I think. It kind of depends on what angle you're viewing the ship from, what maybe is the best color for those scratches. But it's a nice effect, and I want to be able to use this on a lot of different ships. So we need to come up with some better ways for it to be applied. And the problem is that it needs to be applied like per facet of a mesh. So like we want to be able to easily apply it to every facet of a mesh independently. And I'm having to rewrite that logic every time. So let's try to fix that. Okay. So this garbage. Okay. I hate adding more code to details, but let's just start there. And like I said, some of what we're going to be doing tonight might not be the most glamorous thing, because there's some heavy-duty refactoring that's going to need to be done here at some point, but got to start somewhere. Where this should go is in Create Util 3D. Let me just make sure if there's yeah, see, we have all of this code like this. Oh, okay, yeah, this is actually what I want to use. Facets normals all. Yeah, see, like that. That's actually probably what I want. But let's just do this as long as I'm thinking of it. So I was picturing a function like this, like find facet normal. Yeah, not normal. Oh yeah, that's not the... Yeah, okay. So this just is going to do every step of it. And let's see here, yeah, details dot find panel rotation. Normal is going to be, let's see, select dot find face normal of mesh 0. And then debug check. We're gonna do something more complicated here, which is gonna find all facets and assert that the length of the facets is 1. So I could see some real bugs showing up here if this isn't true. We don't want to have to do this check because it's going to be somewhat time consuming to do it all the time. But I just want to have that option here, so we'll do that. Okay. Yeah. Now I like this, because I think the way I would have done this before is yeah. There's different ways of doing something that I kind of wanted to, but like, that I've done other ways, but it's good to revisit these things. Oh, nice. My keyboard's crapping out on me. Let's see. I'll have to swap it out if I'm doing this. Okay, so. Rotation. Oh, shucks. Oh, yeah. See this? I like this. Let's make sure this still works. Yeah, so like just so you guys can see what's happening here. So on certain panels, this function is being invoked, and we're adding these details here. So you can just see what's going on here. I'm gonna actually rename this here in just a second. So these are the extra detail on these different panels that we're generating. And the way these are being constructed, there's no like booleans or anything until the end when we add these little notches. It's all constructed from loops that are kind of built up in a hierarchy and then connected with triangles. So, okay, let's see. Now what I'd like to do is I'd like to abstract out this stuff. So, something that lets us apply a function to every facet of a mesh and handle these rotations and inverse rotations, so we don't have to think about this. I don't like to rush to build these kinds of abstractions, right? But I know I'm going to be doing this on several models, and these model functions are just getting way too big. So okay, let's see here. I think this should go in Google Util. And oh god, so much crap. The size of this code base is getting out of control here. So let's see here. I want to make sure I don't rebuild something I already have. So I have this functionality that kind of does this, but it is it's sort of like doing it just for one one mesh or one part of a mesh. It's not doing it per facet, right? And what I want is something that I can apply per facet, get a result mesh for each facet, and then I can join them back together. Right, and this is just doing it once. There's no loop in here, so okay. So yeah, this operates on a part. I want to operate right on a mesh. So I already have something called like apply facets. Oh, I've got splitting by facets. And see, I might want something eventually that doesn't necessarily have to work on facets, but can just work on like face sets. But here I'm assuming that they're facets, because there's a standard like known normal and like rotation to flatten it out and center it and take it back for a facet. You don't have that for a face set. So let's see here. Let's call this something like oh, nice. Hey, Doug, it's good to see you. Yeah, it's been a while. I've been super busy with my day job and just stuff. Oh, thanks for the whatever you call it. That's very welcome. I've been meaning to try to use some of those myself. Yeah, I've just been very busy with my day job, and I'm doing some really cool stuff in my day job that I've been wanting to do for a long time, but it's like I'm just zapped of energy. I still have been working on my projects, but I'm like, oh, I just want to get cozy under a blanket and not talk to anybody. But we're gonna get back into this for sure. I've been doing some cool stuff and I want to share it. So, okay. Like, so much here, I don't even remember what it is. Let's see what this Creeble from Spice Wife Max was. Okay. Yeah, I think I remember this. See, some of this stuff is like so case specific, it should probably be gotten rid of. And then there's other stuff like this that's going to be very, very general. Okay, so here we go. What was that? Yeah. Okay, Greeble panel top. We're gonna just call this apply facets. So we're gonna have mesh. And then we're going to have a function that's going to take a mesh and return a mesh, but the reason that this is going to be useful is to each facet of a mesh in the coordinate system of the facet. So this function can assume that we're operating on the facet mesh and it's just in the X and Y plane. Z equals 0. So it's going to be in the XY plane. Z equals 0. Okay. And this is going to basically be oh, and I should, let's see here, whether we want an additional rotation. Let's see here, use additional rotation, because that's something we may or may not want to use as well. All right, so facets. Actually, we can do this simpler here. This is the other approach that I was talking about. So the rotation that makes it flat is details.find panel rotation normal, and then so we're gonna rotate it flat. Actually, let me just see here. Let's just do this a little bit. Let's just do this a little bit nicer. A little bit, as long as we're writing this out. Oh, yeah, that's, shucks, that has to be in there already. That's why that's written that way. Okay, because this function needs to have this mesh in that flattened rotation before it'll work. Okay. So yeah, and that's why I named it row flat. So facet equals. So this additional rotation business, what it does is if a panel, if the facet has two edges that are parallel, it aligns those parallel edges, because I'm usually working on ship paneling, and I want to make sure to be doing these operations in a coordinate system that makes sense for a panel. So you want certain things aligned, so you have to make certain assumptions about how things are rotated. Okay, so we're going to rotate the mesh by row flat. Then if add is going to be details.find additional rotation facet. Oh shucks. This isn't. Yeah, that's facing the Z's. apply it again. Add. Okay. And then here, it should be flat already, so we don't need to do this. We just want to flatten the whole mesh. So Z offset, it should be able to just take the first mesh facet. Okay, now we're ready to call the function facet new. Let's see here. See, it's not really a facet anymore. We'll call this greebled or updated. Let's see. Slunk facet. And then we've got to unapply these different rotations and translations. So, and we'll just call this up. This up. So, translate mesh. This up. This offset. So that puts it back where it was. And then if we're using tape mesh up, transpose, facet equals dot tape mesh. Oops. Oh, and this, yeah, we're going to, what is this wrote new business? Where is this coming from? Oh, that's that. Which, like, for this, we can actually ignore. That's another nice thing about this. I'm seeing, as I'm going through this, I'm seeing these redundant things that we can get rid of. That'll simplify things. Yeah, okay. Yeah. I'm not even going to refactor this now because this is just going to be refactored. Okay, so res.append. This isn't res, we'll call this facets updated. It's updated.append facet up. Okay, now we're going to join everything together, which here we're processing or concatenating with the process. So res is going to be process validate cat just trying to think if we would, do we want a version of this function that doesn't do this? I don't think so. I think we always want it. I think we always want to do this. In this case. Yeah. Okay. And then this is what we return. Oh yeah, that's funny. I actually wrote this to not do that, but I think that's also something that we just want to do all the time. Okay. So, let's see now if this can replace our code here. And we're not even doing any of this anymore. Yeah, it's odd the way these different things get. Why am I applying this here? Yeah, this never was actually needed. This wrote new business. Okay. Let's just get rid of this. This gets a lot simpler. Facets new. Yeah. So this is just going to be facets. This is going to be a little bit more complicated than what I'm doing there, but that's okay. So is going to be true, and this is just going to be let's see, Greeble. We'll just call this Greeble facet mesh, and this is where we have to do this. But we don't have to do that Z offset anymore. Facet mesh. And oh, shucks. What was I using? Oh, I was using that as like a hash. That's the other thing that we want. We want a got to think about this. So I was doing something here where in the function that I was applying to each facet, I was using an index as kind of like a source of randomness or variation. I've got to think, is there a better way to do this? Okay, I think for now, and see, I don't even know, like when I find these facets, how the order is being determined, if that's something that is going to be like consistent across platforms, so it might not even matter. It might be better. Yeah, you know what? This is good. There's a better way to do this anyway. A better way to do this anyway. Okay, so we don't have to worry about that. We've got a better way to do this. We're gonna pass in an RNG into our agreeable func here. So yeah, we don't need to worry about that offset anymore. And we're just gonna go like this. So turn this is not the most glamorous stuff here, but it's good to think about. Okay, so this is, yeah, agreeable facet, and let's just go ahead and get rid of this, so we're not even thinking about it anymore. And yeah, see, it's so awkward how I was doing this, because this is just this is going to be a new mesh top, right? Yeah. Otherwise, yeah, we're just going to concat mesh top with mesh bottom. Yeah, jeez. Okay. Make things way too complicated. Let's mesh top. Next, oh, okay, yeah, that's right. We gotta add, that's what that is. So facet, we're just gonna do this mesh facets equals bottom, top, and that's not facets. That is this is just meshes, right? Meshes, dot append mesh top B, and cat meshes. Okay, that clears things up big time. Okay, now this is what we got to get straightened out here. So instead of doing this, we're just going to pass the RNG in. State. This only really would have made sense if these facets are being processed in a consistent order. And just for good measure, well, actually, we should test this to make sure. That this works before we do too much further. But once we get this working, we're going to combine this together, because whatever. Okay. And just to preemptively, let's do a little visualization in here. So let's look at the mesh that we're going to be doing this on, and let's look at this. And look at this. Okay. So okay, good. This seems like it's working. Seems like we got it working on the first try. Yep. Okay, awesome. Now, yeah, let's just go ahead and refactor this to every facet of a mesh, and then we can go ahead and let's see here. A little funk. Oh yeah, no, not this is not what we want. To a mesh facet. And yeah, all we need to do is just pull this in here. Outer facet mesh. And where am I using RNG in the outer scope? Yeah, that was just a false flag. And we'll just call this panel rand. So, okay, yeah. See, now this is all specifically panel greebling functionality like we want. Oh, this didn't. Yep. Okay. Now see. We could probably refactor this random stuff too into one of these functions. That might be a nice test. As well, because it's going to look a lot the same. But I don't really care about this, so that might be a project for another night. These guys. Okay. Actually, yeah, just for kicks and giggles, let's try to implement another, because this was basically doing the same thing, where we're applying a function to every facet of the top mesh. Yeah. So this one doesn't need the RNG. And we don't have to worry about this rotation. So we should only need this stuff. Can I see a reason why this isn't going to work? No, I can't. So let's bring this stuff in here. Let's live on the edge. Just get rid of this. This stuff we don't even need either, because let's see here. Interesting. This is left over. Oh, this is all this stuff. That's funny. Okay. So we've got to get, yeah, so this stuff has to be passed in. Interesting. Actually, let's just pass that in as rock info. And yeah, like this. And see, like all of this stuff. This. Yeah, we can even get rid of a lot of this because we know that it's going to be at z equals 0 right now. Okay. So, yeah, so counts, scales, oh geez, see, there's a ton of this. This was an old, like, procedural, like, non-random sampling kind of method that I came up with before I just figured out how to properly do, like, a seeded NumPy RNG object that can be passed around. This stuff I might use more in the future if I can figure out a nicer way to do it. You just end up with all of these objects. Like, you have a lot of control over things, but I don't know if it actually really made things too much better. Like having that control over specific values of things. Just for ease right now, we're going to do this. See, we don't need this anymore because we know that z is 0. And then we're converting to 2D right away there. Doing all the stuff, doing all the sampling. And basically res is just going to be triangulating that hierarchy and returning it. So let's turn this guy back on and see if it looks like it's working. I don't see anything that really would have broken. Yeah, let's just view the original mesh here when we're invoking it. Yeah, see. And I think, yeah, see, like counts. So yeah, counts as 0 sometimes. So you can see what this technique is doing is it's just adding like these little tiny panels sometimes. Yeah. Alright, this seems to be working. I'm going to get rid of some of these outputs. So this is going to be roughly like, actually it should be almost exactly like what this method looked like before, and it can be easily toggled, so that's nice. Oh, fail with bad polygon. No. That's funny. Oh, that's why. That's why. Problem solved. No. Yeah, this is basically. That's so dumb. This is basically what I want. So now let's clean this guy up a little bit. And see, yeah, like just to, you know, confirm here, right? Because of this wrapper, right? Because of the way this wrapper works. Apply facets. Every mesh that comes into here is going to be flat on, it's going to be a facet, you know, one or more polygons that all are contiguous, lying on the XY plane. Oh, nice to see you, Jupiter BJY. Yes, the thruster thingy does have glowing rings. I'll actually bring it up here in just a second and show you interactively. I'm really happy with the look that I came up with for that, and I think you might be interested to see how the glowy rings got done as well. It's the texture is a shader in Blender. So okay, so yeah, we want to rename this guy to facet mesh. But yeah. Yeah. Okay, so yeah, like you can see here, if I run this now, every time this is invoked, the initial facet is just sitting there on the XY plane. It doesn't matter. It could be in a number of different places in the XY plane. We don't really care about its translation. We just care that it's there. And then remember I talked about that additional rotation option. You can see that basically if there are parallel sides, that those are aligned in the x-axis. Yeah. See, sometimes it's quite far off from the origin, but that doesn't matter. Okay. But now, see, the awesome thing about what we've done is, oh, let me check my music here. I might have run out of, yep, I ran out of music. Let's take something a little bit more mild for nighttime now. See, we can really easily just toggle back to this other method now. Oh, this is so... Yeah, we don't even care about rote new. This. We can actually put this right in here. Look at this. So we'll swap back over to the new method. This is a lot nicer. I'll just say mesh. B is none. And assert. See, it's complaining about this, but we can assert this instance. Mesh. And oh, that's so nice. That. So nice. Okay, so yeah, there's the new method, and let's bring it up in Blender now and take a look. Okay, I see one problem. It looks like, oh, it looks like we're getting the same sampling from the random number generator each time, so there's something I'm not doing right there. Let's... That's weird. I gotta fix that. Oh, yeah. That's what's going on. Yeah, I gotta bring this up. Because really I want this up here, and I also want to seed this with a hash of with like a hash of the part name. Yeah. So RNG is this. Okay, so Jupiter BJY asks, were engine pods supposed to get different paneling? So I have separate methods for the engine pods because they're curved surfaces. So a lot of the stuff that I'm doing for the fuselage, like, is assuming that we have big flat surfaces. The drive pod paneling is special stuff that is like kind of like working in a mesh space, and yeah, on meshes. So this, yeah, all this stuff is just more like for the big flat surfaces on the on this. Nice. I see Sky Limits Animatus says hello. How's it going? Yeah, so and this method, so this panel, I call it panel rand, is kind of it's supposed to be kind of a artistic thing where like the general approach is like you take a panel and you make a couple slices over from one edge along one dimension, and then you take the remainder and then you slice it along the other dimension. So the idea is that it looks interesting without looking random or too random, and could be kind of functional. So I like to design things that look like they have a function and don't look like just random greebles for the sake of random greebles. I could actually take this method over to something that would function on drive panels. I don't think that would be too hard. But I have some stuff in the works that might, I don't know, sort of change how a lot of that stuff works, so I don't want to mess with it too much now. And there may be like in-universe reasons why the drive panels on a ship like this would kind of have a different style and look to them than the big panels on the fuselage. So Sky Limits Animatus says, is this a game or software? So I'm using the Python programming language and to generate models for for my sci-fi universe, like Jupiter PJY says. And there's sort of two applications here. There's a sort of low detail, low poly version of these things for a game that I'm working on. And then this, what I'm working on right now, is like a high detail driving towards like realistic 3D art that I'm rendering in Blender. So I'll actually show you what this looks like in Blender here. And the goal of the Blender stuff is I'm not quite there yet, but the goal is to like make realistic stuff that looks like TV or movie level VFX. That's kind of probably a little bit of a stretch goal, but I think it's something that's still worth going for, and I can show you some of the headway that I've made on that as well. So here's what the ship looks like in Blender, and the big thing that I learned, because I had a bit of a vacation this summer and I got to work on this project over a number of days, is that compositing really matters. So actually, as long as we're all looking at this, let me bring in my nice stars. Is that compositing really matters a lot. So adding stuff like glare, lens distortion, all of that stuff really matters a lot. And the other thing that let me do is film noise. The other thing that let me do is let me start using realistic values for sun strength, and instead of having to like tweak material colors all the time to get it to look like I want, I can control the exposure. So the only thing that's a little bit inconvenient about that is like if I turn the compositor off, it's like completely blown out, and like you have to turn the compositor on and off like when you're using material preview and stuff like that. But for the most part, it's not a big deal just to leave the compositor on. But if we go back to rendered view and turn the compositor back on, and see, this is a new thing. Like, I don't think Blender had compositor view in the viewport a few years ago when I started using Blender. So yeah, so a lot of these things really make a difference. Like if I go through and start muting some of these things, I mean, it still looks nice, and there's a nice it's got a nice clean look without this, but especially like when you start actually rendering and using the denoiser, you want to add you want to add noise back in, otherwise it just looks too clean. Yeah. I'll show you something else too. Jupiter BJY. Well, here, just as long as we're in here right now. So this is that drive glow, and let me just bring you in here. So this these little ridges, that's actually a shader that you might appreciate this. So it generates segments using the angle around the mesh, and you can control like how many segments there are and the fraction of space in between. So I could do a smaller number, something like that. Different look. I can control the brightness of it. So Sky Limits says the lighting is so realistic. Yeah. The way the lighting is done is super simple. There is basically a sunlight, and then there's a planet light that is aiming exactly the opposite. You turn the planet light off, you get this really nice, like dark, like super bright space effect. But what I think really sells it is that glare. So if you turn the glare off, it loses a little bit of the effect. The other thing that I think I discovered probably since you've been in the chat, Jupiter BJY, is that a big thing that I was missing is that I needed a narrower field of view for my camera. So I think by default, a lot of times I think it was maybe like a 45-degree field of view, and if you let's see here, where's my camera? So with that, field of view, you get this just kind of like more distorted look, and I found that the smaller field of view, it just looks more like the kind of images that you see when you know, like when you see space art. So that was like something that really made a lot of these pieces start looking more like I was picturing in my head. So that was a big help. And Sky Limit says, I never knew Python could do 3D stuff. So yeah, there are a lot of different options, like Jupiter BJY is saying. for me, I'm using a couple of libraries. One is called TriMesh for doing 3D mesh processing. That's an important one. But for visualizing and rendering, I'm using Blender. And if you don't know, Blender, you know, it's like free open source software. But Blender as a scripting language has Python built in. And the way my project works is that I kind of generate this file that represents like a sequence of commands that Blender's going to run to build my scene, like loading in different meshes and applying different things. And then I start up Blender with a script that loads in that file and generates that scene. So the idea with that, as opposed to like maybe writing code that runs right in Blender, is that I can generate models that go different places. Like they could go in my game, or like another thing that I do is I 3D print. I 3D print stuff. So just to show you here. So let's see here. So like here's this ship that I 3D printed, one of my models, and this stand. And my 3D printing process doesn't involve Blender at all. It's just completely separate. So I like kind of keeping different things separate, so I'm not like depending completely on one particular software to do what I want to do. And then I was just going to show, I'm probably going to, well, probably keep going for a little while, but I'm just going to show something here. So this is a version of the same ship here that I was working with manually the other day. And this, I've got a really, really nice looking tweak to the shader made for. I tweaked some colors. There isn't really anything different about this stuff other than the colors, so that's an easy change. I did add ghost glare in the compositor. That's something that I need to add programmatically, but I came up with a new shader for the spacecraft skin, which I like quite a bit better than the current thing that I was showing. And what this does is it uses the brick texture shader node several times to kind of make something that looks like different, like slight variations in the paint color in rectangular patches. I feel like that's something that you see in a lot of space art as a way to kind of convey scale. If you have a bigger ship, the paint texture is not quite even. Like slightly different colors of paint were used on different patches. And something like that is going on in the current texture, where the noise is sort of like rectangular patches of color, but this just makes it a little bit more well defined. And the cool thing about this is it holds up pretty well to zooming in farther, I think. Like even like on the rear of the ship, where I think the other texture just looks kind of bad. Like, I mean, this could still be improved, but I think it's like, it's getting there, you know. Not perfect, but it's something that holds up pretty well to zooming quite far in on. And yeah, Jupiter BJY says that 3D printed one is lovely. Yeah, thanks. I was working on the 3D printed stuff a lot earlier this year, and I made some really good headway with that, and I'm kind of excited now with some of the updates that I've made to some of these designs for larger ships to go back and try to print them as well. So Skylimit says the chromatic aberration-like effect in the spots where light falls make it look really cool. Yeah, so that chromatic aberration effect, that's actually part of the lens distortion node. So there is a dispersion and a distortion aspect to the lens distortion. So like, and you'll notice, let's see here. Oh, that looks cool. You can see the, I don't know if it's showing up on YouTube, but you can see the ghost glare there a little bit. Oh, that looks awesome. You can see it does the chromatic aberration a little bit more towards like the edges, like farther out edges. So you can see if I turn the lens distortion off, it eliminates that as well. And you could crank it up or down, like it's at 0.02. If I turn this up to yeah, it gets really extreme. That's definitely too much, but it's kind of a cool look. Setting up a good, like a better compositor setup was like one of the best things that I did for this project, because it just really takes things to the next level. And it's easy enough to turn all, like any of the components of this off, if you don't want them on. So Jupiter BJY says, yeah, with low FOV and high distortion, it pretty much gives expanse style long range zoom feeling. Yeah, exactly. And something really cool that I did too, I don't know if you saw, I think I might have talked about this on a stream at some point, but I have this, so this is just using a texture, but I have, I'm using for the stars, I'm using this Blender asset that I found called Real Stars, and I have it set up so that I can, the star size changes with the FOV, so I can do zooming. I can actually change the zoom, and the stars don't get bigger or smaller, right? The stars stay the same size. So you can see here, you can see like this, the size of that star. If I go into the camera and I make this field of view, let's see, that zooms in, so that doesn't work. Like if I make the field of view wider, the stars stay the same size. So you can do stuff like you can do stuff where you're talking about, where you could start like zoomed out and then like zoom way in and get that effect. I'm just trying to think if I can set something like that up here quickly, because it looks really cool. Let's see here. So I guess 40. Let's see if we move it for just further away. Let's see, where's my camera? Yeah. So I just move it further away. So like if I go from 40, in like that, you get that cool effect. Yes. Yeah, exactly. Sky limit. So it makes the stars look like they're actually far away. Yeah. um, because stars are so far away that they're just basically like little points of light. So they don't actually zoom. They don't get bigger when you zoom in. I'm sure they change some in the camera. But yeah, and Jupiter BJY. I don't know if you saw this, but I actually did something like this with the game as well. So I got fed up with the the fact that I was kind of stuck with these skyboxes, and I made my own skybox for the game that you can zoom in and out of with the stars not changing size. Let me see if the game runs, because that's a really cool effect, and I know you would appreciate it. I was actually playing. I was playing. I was playing MechWarrior 5 Clans. Okay, I don't have the skybox set up in this mission. I was playing MechWarrior 5 Clans, and there's like this really cool zoom functionality there. And I was like, I want to implement that in my game, but then I remembered that that you know, like I'm using this skybox, and you know, you start changing the camera field of view, and you know, you just zoom in on the stars and it looks awful. Let's see, where was that? It was in one of the missions. I think it was in mission 4. Yeah, this is it. Okay. And I don't know, hopefully the stars here are showing up on YouTube, but I think the default field of view that I have is something like 60. But like, check this out, this is so cool. Look at that. And then you get that cool expanse, like long range zoom look. And you keep the tiny stars. They're actually like little diamond shapes. Yeah, it's and you can vary the size. Like I'm actually generating these star positions off like real star positions and using the size, but like you can kind of control how much you want the size to vary. But like, oh, this just looks so cool. I need to get back into the game. I was gonna try to work on that more this fall. So cool. Yeah, and see, like sky limits, if you're still here, like you could have like a larger object like a sun or something, or a planet that does get bigger when you zoom in, but the stars just stay the same size. Let's see if I can get this guy to fire on me. We'll get in a little closer to the action. It looks, whoops. Looks cool from inside the cockpit too. Whew. There's just something about that lower narrower field of view that gets the scale across better too. I don't know exactly what it is, but just things look bigger when you're zoomed in on them from far away. I think it's probably just because like we're used to images of big things being taken from far away, like with telephoto lenses, but that whole field of view thing was just kind of a revelation. But it's something that you have to fight with when you're making a game, because you don't want to have your game camera have such a small field of view. It would look really weird. Like you wouldn't want to sit and play the whole game like this. But being able to zoom in is really cool. Go after one of these smaller guys here. See if I can destroy him. Boom. Okay, that's enough of that. Yeah, the drive ring glow helps on so many levels too. It's just something that's quite long overdue. It's one of those things that I think in my setting I didn't really imagine. I imagined radiators glowing, but the drive ring glow it's just kind of like important for readability too. Yeah, the lore reason for the glow would be that that it's just like a side effect of how the drives work. So basically they're like these kind of like giant electric motors that spin, and they have something that I think I call like entropy meshes in them that are basically just like I'm imagining like a bunch of like little tiny relays that just like turn on and off really fast, and they spin. So it's like these little tiny relays that are like turning on and off really fast while the drive sort of like the ring that they're on spins, and that like creates this effect that kind of like warps space or pushes against the ether, or generates a gravitational effect that pulls or something, right? But I think you could explain the glow as, you know, the devices create, like either the devices create light or the effect creates some light, like you know, like a glowing shield. You know, when you hit a glowing shield with when you hit a shield, a force field with something, like that energy has to go somewhere, and some of it turns into light. So you could imagine these devices as like being like a light bulb, where, you know, like a light bulb, you're pouring a bunch of electricity into it, and a bunch of it turns into light, but some of it turns into heat. Like, well, this device, you're trying to get this thrust effect, but some of the energy just turns into light. And then I'm kind of developing more of the lore for how these things work, and I think what I'm thinking about now is like there's kind of an art or black magic to how the ether sort of flows through these devices. So in some of my earlier ship designs, like this one that I 3D printed. Let's see here, like the needle. You have the engines that kind of have like an exposed rear, but the front is kind of like tucked into the ship. And this would probably work, but like maybe it might be more efficient if more of the front of the drive was exposed to space. So like that might be why they glow, right? Is the way the geometry of the ship and the drive is laid out for optimal flow, you know, whatever that means. It ends up exposing those devices to it ends up exposing those devices to space in a way that the light is visible. But like maybe that's a trade-off that you make, right? Like for a fighter, you trade off X percentage of efficiency to have the front of the drives, you know, walled off by some material that doesn't let the light escape, but then the magic ether flows into them a little bit harder, right? So you don't, they're not as efficient, but then you don't have that light signature from the appliances at the front. So some different ideas there. Okay, well, I think that we're at a pretty good stopping point for tonight. I did my little refactoring that I'm pretty happy with. And we looked at some good stuff in Blender. It was fun catching up with you, Jupiter BJY. Yeah, so he says if the drive is fully exposed in the stream of those particles, it would glow and have optimal efficiency, otherwise no glow. Yeah, that's exactly what I'm saying. So the idea is that these drives engage with some kind of parallel universe, essentially, where they can either act like propellers or do something with this kind of like, I imagine it kind of like a thick fluid that can dissipate energy and you can kind of manipulate in different ways. And then we'll sort of interact with our world in limited ways. And it ordinarily just flows through things, right? So like, you know, you throw a baseball through outer space, it's not interacting with this stuff at all. But these drives, you start pouring electricity into these drives, this magical thing happens where all of a sudden the drive can engage with this stuff. And it's going to work even if it's boxed in, but it might not work as efficiently. And something I've been thinking about too is how does the effect of the drives interact with the effect of shields? Because both the drives and shields are kind of variants of this magic technology. So there might be ways like, because, you know, we don't care about ships being aerodynamic in space, but we do care a little bit about optimizing the shape of them so that shields can be projected over them efficiently, and so that drives are, you know, exposed or arranged in such a way that you get that optimal flow of the ether. So yeah, I think you're getting it. And these are very vague ideas. My priorities for this is just like, number one, being able to tell good stories. Number two, making the kind of designs that I want to make, which is something that's like maybe more realistic than Star Wars, but less realistic than hard sci-fi, right? And this kind of like, but designs like Star Wars in that they're sort of like basic and not too complicated. you know, kind of built of simple shapes kind of look recognizable and familiar. So yeah, so Jupiter BJY says that makes sense. Feels like putting glass in front of solar panels. Light will flow, but slightly less. Exposed fully for max output at the cost of environmental damage. Yeah, exactly. That's something that like I'm thinking about as I work with these designs. Is like, how would you arrange things on ships so that, you know, like you're balancing a few different things. Like you're balancing where the drives are, where the thrusters are, which like on this model are these triangular things, and then like where the shield generators are. So like you know, like maybe you get like the highest efficiency shields if you put shields like right at the tip, but then your thrusters are going to be more efficient if you put them right at the tip. So it's like there's a trade-off there that you'd have to make with the efficiency of your different components. But just ideas that are being baked very slowly over a long period of time. Well, I think that's it for this evening. Thanks everybody for hanging out. I really appreciate it. It's fun to work at night on this project and have some people to talk to. So I hope that all of you... No, you're not holding me at all. I'm just hanging out here. But I hope that all of you who are watching have your own cool projects that you're working on. I hope this encourages you to work on your projects, and maybe next time we can work on projects together. And I'd like to hear about what you're working on as well. So yeah, thanks again, Jupiter BJY. Thanks, Sky Limits, Animators, and Doug. And thanks everybody for the boosts or whatever they're called. I really appreciate it. Yeah, and I'm gonna stream again soon. I've set this aside for far too long. Made some good progress on my project, but set the streaming aside for far too long. So, all right, have a good night, everybody.